So what is the construction of our PV system? Simply, for an off-grid system, which we are going to discuss how to design it, the first thing is the solar panels. The solar panels, its purpose is to take the sun radiation and convert it into electricity, okay, DC electricity. Now the DC electricity goes to something which is called a charge controller. What does a charge controller do? It takes the DC current here and DC voltage and regulate the charging of the battery. Okay, we are going, of course, to discuss the benefit of the charge control more in this course. But we are talking now an overview about the solar system. Now we have the battery banks, which are going to store the energy from the solar panels. Now we have an inverter to convert AC to DC to generate AC power to our house. We also have here an optional generator in if we don't have battery banks, or if we would like to have an extra generator for generating power when we don't have, or when the solar system does not produce enough power. Okay, this is an optional solution, but it's not recommended because it will cost you a lot. So what is the advantages of the PV systems? Number one, it provides green energy. This energy is from the nature, and it is a clean energy and nearly have a zero pollution. It is free and available energy. This energy is taken from our sun. Can be used locally, which reduces losses. Okay, what does it mean? It means that we can use it near us just by putting the panels. We can take the energy right from it. Okay, but if we are talking about the grid of the government, they generate the electricity at generators, then transmit it using transmission lines, which causes losses, until distributing it using distribution substations or distribution transformers, which also causes losses, then through underground cables until it comes to you. Okay, so all of this system causes losses and costs the government lots of money. Okay, so the PV system reduces losses and more efficient in cost than building a generating substation and providing power to you. The operation and the maintenance costs are low in the system. It is silent, no noise. The reason for this is that it has no mechanical parts, not as the generators in the generating power plants, such as the synchronous generators, which have mechanical parts and or mechanical moving parts. It is, of course, easy to install. You can install it by yourself. It is used in spacecraft applications, satellites, for example. But the disadvantages of the PV systems: number one, there is no power at night or during cloudy or rainy weather, because during this time there is no sun. Okay, so there is no power during the night or cloudy or rainy weather. It requires additional equipment such as inverters and batteries. The reason for this is that the power generated from the PV system is DC power, or a direct current, or a steady voltage, or one directional power, one directional voltage. So we need to use inverters to supply AC powers to convert the DC power to AC power. And if you would like to know about inverters, you can go to my own course for inverters. It requires batteries in order to store the power during night or during cloudy or rainy weather, to be used during these conditions. Okay, so we store the power during the day to be used at night or cloudy or rainy weather. Okay, the batteries are really expensive and represents a large percentage of the PV system cost. Okay, when we are talking, of course, at an off-grid system. Okay, and in this course we will discuss the difference between off-grid and on-grid system and hybrid, of course. The PV system actually have a 15 to 18% efficiency or a low efficiency. This means that we can only benefit from 18%, maximum of 18% of the radiation of the sun. It needs a continuous cleaning from dust, of course. For high power, PV requires a very large area, for example, a desert. Of course, it is difficult inside the cities because we don't have a large roof for PV. So what is the construction of PV cell, or how does a PV cell work? So we'll find here that here we have one PV cell. Okay, now this PV cell having or receives the solar radiation and converts it into electricity. So how does it work? Okay, the first thing, it has here a non-reflecting surface. This non-reflecting surface or anti-reflecting coating is used to prevent the sunlight from being reflected from the panel. Okay, because we would like to absorb all the radiation. So that is the first thing. We use here an anti-reflecting surface in order to absorb all the radiation. Second thing, we have here an N-type silicon and B-type silicon, and between them a depletion region. If you understand electronics, you will understand how does this junction work. It is a PN junction. So what happens here? Simply, the N-type has an excess amount of electrons. Okay, and N-type silicon has a large amount of electrons or excess amount of electrons. But the P-type silicon has a large amount of holes. Okay, these electrons wants to close these holes. Okay, simply. So this electrons wants to go to these holes. So what happens here is that when the light falls on the N-type silicon, the electrons gain amount of energy, which is enough for them to move from the N-type layer to P-type layer. Okay, so when the electrons moves from the N-type to P-type, it causes electron flow, which means the flow of electric charges. Okay, which means the flow of electric current. Okay, simple as this. Now again, the light energy passes the anti-reflecting surface, causing the silicon electrons to gain enough energy in order to go from here and pass and go to the P-type silicon. Okay, in order to fill the holes. Okay, so the electrons gain amount of energy, passes through these wires, then go and fill the P-type. The depletion layer is used to separate between these two, between the N-type and P-type. Okay, so when electrons have enough amount of energy, it goes from through the wires and to the P-type silicon. Okay, so the movement of electron here will cause the electron flow or electricity flow or current flow. Okay, types of the solar photovoltaic cells. Solar panels convert energy from the sun into the electricity which we use in our homes. Of course, to power the lights on our streets, the machine in our industries, and of course we can use it in our home. There are different types of the solar photovoltaic cells. There is the monocrystalline silicon solar panels. There is the polycrystalline or multicrystalline solar panels, the amorphous or a thin film solar panels, and the hybrid silicon solar panels. The first one is the monocrystalline. They are the most effective of the solar PV cells with a 15% efficiency. They also are considered the more expensive option because they require less space than the other cells simply because they produce more energy and can yield up to 4 times more power than the thin film solar panels. They also last longer than the other panels and perform better at low light. Their own main disadvantage is their cost, which means that it is not the first choice for homeowners because it is very expensive, despite its large efficiency, which is 15%. It is also can be affected by dirt or shade, which can break the circuit. The second type is the polycrystalline or multicrystalline. They have an efficiency of 13%. They are often seen as the better economic choice, particularly for the homeowners because they have a lower price than the monocrystalline. They are made from a number of smaller silicon crystals that are melted together and then recrystallized. The main disadvantage of it means that you will need more of them because of the lower energy conversion efficiency. As you see here, in the previous one we have an efficiency of 15%. That's why you will need a less space and a less amount of them. But here for the polycrystalline, it has an efficiency of 13%, which means that we will need more of them because it has a lower efficiency. The third type is the amorphous or thin film solar panels. They have a 7% efficiency. Therefore, the thin film or the amorphous are among the least efficient on the market, but they are considered as the cheapest option. They work well in the low light, even moonlight, and are made from non-crystalline silicon that can be transferred in a thin film into another material, such as glass. The main advantage of it is that it can be mass-produced at a much cheaper cost, but is more suitable for situations where space is not a big issue. For example, in a desert, if you have a large space or a large amount of area, of course in the desert we can install the amorphous or the thin film type. But for the homeowners, we cannot use it because it have a low efficiency 7%. So we will use the polycrystalline type. The main disadvantage for them is that they are not generally used for residential purposes or for the homeowners because they will degrade quicker than the crystalline cells or the polycrystalline or the monocrystalline, and they have a low efficiency of 7%. The hybrid silicon solar panels. They have the largest efficiency with an efficiency of 18%. The hybrid solar panels are made from a mix of the amorphous and the monocrystalline cells to generate the maximum efficiency. There are a variety of types of the hybrid cells and they are still very much at the research and development stage, which is why they are currently a more expensive option. Now the summary for the PV cells. The first type is the monocrystalline. They have efficiency of 15% and they are considered one of the most effective PV cells in the market. The polycrystalline or multicrystalline, they have efficiency of 13%. They are also cheaper to produce and slightly less efficient than monocrystalline. The amorphous or the thin film silicon, they have the lowest efficiency, 7%, and one of the least efficient cell types on the market, but they are considered the cheapest. The hybrid silicon, they are a combination of the polycrystalline and the monocrystalline, and they have the highest efficiency, 18%. They are the most expensive PV cell type available on the market, but also the most efficient. So the first thing that our system or our PV system consisting of a group of modules, strings, and finally arrays. So what does a cell module string array means. Okay, cell represents the smallest part or the smallest component in a PV system. This cell is used to convert the solar energy into electrical energy. This cell produces from 0.5 to maximum of 0.9 volt. Okay, so this cell is used to convert the solar energy into electrical energy. Okay, now a group of cells like this one, a group of cells in series, all of these cells are in series, forms something which is called a module. Okay, so a group of cells in series forms a module. Now we have this one which is a module. Now a group of modules in series will produce something which is called a string. Okay, so the cell is the smallest component in our PV system. The module is consisting of a group of cells in series. Then the string is consisting of a group of modules also in series. Okay, now the array, which is the biggest thing in our PV system, is consisting of a group of strings in parallel. Okay, so this one is a string consisting of two modules. So this one is a module, this one is a module, this one is a module, this one is a module. Two modules in series will form one string. Two modules in series form a string. Two modules in series a string. Two modules in series a string. Now all of these strings are in parallel, forming an array. Okay, the string does not have a specific number, at least two modules in series, okay, or one module in series. The module is consisting of a group of cells. Okay, here is an example of how does this work, or how a string is formed. Okay, you will find here this one, a cell, 6 volt and 3 amp, 6 volt and 3 amp, 6 volt and 3 amp. If we connect these panels or these modules in series, we will have a final voltage of 6 volt plus 6 volt plus 6 volt, which is 18 volt, same as a group of batteries in series. Okay, positive, negative, the negative is connected to the positive, negative, positive, same as a group of batteries in series. How to connect our PV cells in series and parallel, and the effect on the VI curve. So first, you have to consider that each of these cells or each of these modules, to be more specific, is like a battery. Okay, so when you connect a group of batteries in series, for example, if this battery is 0.5 volt, 0.5, 0.5, 0.5, and if you connect all of them in series, as you know that from the KVL law, you will find that the output voltage will be the summation of all voltage. Okay, V1 plus V2 plus V3 plus V4, which will give us 2 volt. Okay, so how we connect them? The module has two terminals, one which is a positive, one which is a negative. Okay, in order to connect in series, we take the positive and connect it with the negative of the second cell, the positive to the negative of second cell, positive to negative, and so on, until you will finally have one positive terminal and one negative terminal. Okay, now here is the same example. You will find here two terminals, positive on the upper and negative on the lower. Okay, now if we connect the negative with the positive, negative, and so on, you will have two terminals, a positive terminal and the negative terminal, and the summation of the voltage here is the sum of the two voltages here. Okay, now if we see here the single cell or single module having a current of 0.8 and 0.6 volt. Okay, this is a cell, of course, not a module. Now which is the same as module. Okay, if we made this one module, it will give us the same values, okay, but the current will be higher and the voltage will be also higher, okay. But since here we are drawing this curve according to single cell, so we have here 0.6 volt. As you remember that the voltage was between 0.5 to 0.9 volt. So here this one is single cell, and if we have two cells in series, the voltage will be the summation of two cells. So the voltage here doubled and the current is the same, okay. The current here I1 is equal to I2 equal to I3 equal to I4, but the voltage is a summation of all voltages here. So one cell here, two cells in series will give us 0.6 plus 0.6, which will give us 1.2, okay. Current is the same, the voltage is doubled. Now if we talk about the parallel connection here, we have one panel here, one panel, or we can say we have a group of cells. It is the same, okay. Now if we would like to have here this cell parallel with this cell, okay, for example these two cells will give us 0.6 volt. This is an assumption, okay. So these two cells, when they are in parallel, the total current increases. It will be IA, the current of the first string or the first line, plus the current of the second line, IA plus IP, okay. So when we connect two cells in parallel, this one is parallel, you will find here the total current increases to double, okay, since they are identical to each other. So 0.8 will become 1.6, but the voltage will be the same since they are in parallel. So the difference again is that the parallel connection used to increase the total current. So we'll find here one cell, two cells in parallel will give us 1.6 or double the current. And the voltage is the same, but here in the series, the two series here, for example, will give us double the voltage but same current. Now let's see the effect of series and parallel on VI curve again, okay. Now if we have a single cell, if we have two cells in series, then the total voltage will increase at the same current. Here one cell, here two cells in series, so the voltage here was doubled or increased to double. Now for the parallel connection, one cell here, two cells in parallel will increase the current to the double at the same voltage, okay. You will find here this one and this point is called the maximum power point. What does it mean? It means that the maximum or the point at which we will have the maximum power. At this point, voltage and current, we will have the maximum output power, okay. So if we would like to get the maximum power from our PV cell, we will have to operate at this voltage and this current, okay. Same here, this point, which is the knee of the curve, is the voltage and current at which we will have the maximum power.